Hello and welcome to Unit 2, which starts with Step 7. In Step 7, we're going to talk all things transformation. So there's 3 different types of transformations. We have reflections, we have translations, and we have rotations. So in this first video, we're going to talk all things reflections, okay? So a reflection, hopefully maybe you're thinking, like when you look into a mirror, right, you see your reflection. You're not going to see the same exact thing, right? A reflection is going to flip the image, okay? And each time we're going to start with something called a pre-image, which it's going to have a corresponding point on the image at the same distance from this line. That's the biggest thing. So think about like when you're looking into that mirror, as you get closer to the mirror, your reflection gets bigger, right? Because you're getting closer and closer to that point that is reflecting. The biggest thing is that we always start out with some sort of pre-image, and our final object is our image, okay? The other big thing is that in all of these transformations, every time we do one of these transformations, the figure should be the exact same. It should be congruent to each other. So if yours does not look like you almost copied and pasted it or rotated it or flipped it, then you did something incorrect. And that's okay. We just need to fix it. Okay, so this first figure, we're just going to reflect the figure over the line. So line K here is our line of reflection. If you want to, feel free to get a ruler out and measure this, but just for the sake of time, we can kind of just estimate. So we're going to move everything to the other side of the line, the same distance away from the line. So C is up here. Maybe we put C down here. And when we do C, because this is not going to be C anymore, we put this little apostrophe, which means C prime is what we can refer that to. So then B might be a little bit harder. I don't know, maybe B is like down in here, but this becomes B prime. And then A, like here-ish. I don't know. Then let's connect them as best we can. Okay, obviously we're not in a graph and we didn't have our ruler out, so it's not going to be exact, but it looks pretty good, right? So the first figure we would just call ABC, our regular figure, and then our image, the new one, would be A prime, B prime, C prime. Okay, so that way we can distinguish which one is the new one, okay? All right, so let's look at it on a graph, and then it hopefully will make this can be more exact so that you can see it. So we have a triangle JKL has vertices. Okay, let me switch these colors up a little bit. I'm going to graph the original triangle JKL. So hopefully you remember graphing coordinates from Algebra 1. So J would be 0, 3. K, -2, -1. L, -6. L and excuse me, and then we'll connect these to make our triangle. Okay, this says that our line of reflection, so graph JKL and its image. Okay, that's a big thing too. We had to graph JKL. Don't forget to do that part, because then you'll get something wrong. Okay, and we have to do the image and line x equals -4. So you do have to remember a little bit how to graph lines. Line x equals -4 is going to be, if we went to where x is -4, we'd go left. Let me pick a different color. That doesn't seem like we're going to be able to see it. We're going to go left to get to -4 on the x-axis. And then if we drew it horizontally, it would just be the x-axis. So we have to draw it in the opposite direction of the line that we're on. So this one's going to go vertically. Okay, so if you want to make a note for yourself, if it's x equals a number, this is going to be a vertical line going up and down. If it's y equals a number, it's going to be horizontal. Going left and right. Okay? So then we still have to actually reflect it. We haven't done anything yet. So remember, our biggest thing is that our points have to be on the other side of our line, but the same distance away. So if we start with J, we can see that J is to the right of our line. Exactly 1, 2, 3, 4 blocks. So we're going to count the opposite direction, 1, 2, 3, 4, to the left side of our line, and J would move over there. Okay, K is to the right. We're going to move directly to the left. 2 blocks. Call this K prime. L is 2 to the left. It's going to move 2 to the right. L prime. And then we're going to connect. Whoa, that's not a connection. Connect. Connect. And connect. Okay. One way we can check ourselves is to make sure that they look the same, right? As if it just flipped over. And it does, which is great. All right, next one. We'll skip that one. We can save it maybe for class. Okay, reflection in the x or y axis. So the last one, right, we just were given a random vertical line and asked to reflect. Sometimes, right, we might reflect over the x or the y axis. That's just a built-in vertical or horizontal line. Okay, so if you'd like, you can just imagine the same thing that we did, the x-axis, and then we flip it, or the y-axis, and then we flip it over. But there are shortcuts for this one, okay? If we are reflecting in the x-axis, we're reflecting in the x-axis if our first coordinates started out as xy, it becomes x negative y. So this means that we change the signs of our y coordinates. Okay, and then the opposite happens in our y-axis. Okay, notice it's x comma y, which we are changing the signs of x coordinates. So you're changing the opposite, right? X-axis changed y, y-axis changed x. Not something that you have to memorize, maybe just a shortcut if you think about it. Okay, but no need to necessarily do that. Okay, so graph ABC. So we're going to graph that to start. -5, 2, 3. B is at 2, 0. And C is at 1, 2. Alright, so a nice little obtuse triangle there. Okay, so one thing you can do if you want is you can write out your points here and show how you're reflecting. No, you don't have to do it. Just sometimes if you want to keep a little bit more organized, you can. But this time we're reflecting over our x-axis. Remember, our x-axis is our horizontal axis here. So that's going to be our line of reflection. So our x-axis, if you remember our little shortcut, if we're flipping over the x-axis, we change the sign of our y's. So we could, if we wanted to by hand, go through and just change the signs of all of our y's. Or if you want, you can do it visually and think A is 3 above, so it's going to go 3 below. B, oh, B, that's fun. B has a y coordinate of 0. It is on our line of reflection. Remember, our reflections have to be the same distance from our line of reflection. So if it's on the line of reflection, it actually doesn't get to move. B just, stays exactly where it is. Because when we change the sign of 0, 0 can't be negative, so it has to stay 0. And then C to above, and it goes to below, which makes sense because if we change the sign of our y, we'd get 1, -2. All right, connect them to make our triangle. And we can see that these are, I know my lines aren't the straightest, but we can see that they're the same pretty much. Okay. All right, let's do this one. Okay, describe the transformation shown using the coordinate notation. So, we can hopefully see that all of our points are flipping from one side of the y-axis, right? If we drew this as our line of reflection, right? Hopefully we can see that this is a reflection in the y-axis. Okay, but we need more than that. We need the coordinate notation. So let's pick a point. Let's say P. P started out at what? 1, 2, 3, 4, -4, 1. And P prime moved all the way over to +4, 1. Okay, so our coordinate notation is asking us to show, using our coordinates, how we actually moved. So if you remember the shortcut, you might remember this. If not, you can just look at how did we get from P's coordinates to P prime's coordinates. And the difference is, notice our x coordinate went from -4 to 4, which means that whatever our x was that we started with, we changed its sign. It became a -x. And then our y did not change, right? It stayed from a 1 to a 1, so that just stayed as a y. Okay, so we could call this a reflection in the y-axis, but specifically in our coordinate notation, our xy became -x, y. Okay, the last little bit is sometimes we might do a reflection in the line y equals x. If you remember, maybe from Algebra 1, it's okay if you don't, the line y equals x has a y-intercept of 0 and a slope of 1. Okay. Also, if you might see this sometimes as y equals x, but we know it can also be seen as x equals y because of our symmetric property that's talking about the same line there. Okay, just this nice diagonal line. So our reflections so far have been a nice vertical or horizontal where we can just count the blocks above or below. This one's a little bit trickier because it's diagonal. So you're almost like looking at it at an angle and then trying to flip it. But we have a nice shortcut here. The shortcut is that whatever our coordinates started out as, we just switch them. We just switch x and y. Okay, so whatever our y was becomes our x coordinate, whatever our x coordinate was becomes our y coordinate. We don't need to change the signs, they just simply switch places. Okay, so we have JKLM, so let's go ahead and graph that. Alright, so we have this weird looking quadrilateral, kind of trapezoid-ish, okay? So again, one way you can think about this is if you want to write out your coordinates. So x comma y becomes y comma x. That's our shortcut for our line. If you want to graph the line, remember it's a y-intercept of 0, so it's at the origin. And we're moving with a slope up 1 over 1. just if you want to give yourself a visual. Okay, if you want to write out your coordinates or start doing that, that's fine. Maybe I'll just write out a couple to show you. Okay, so we start with J at 2, 2. When we switch those coordinates, nothing changes, which makes sense because 2, 2 is on our line of reflection. Remember, we don't move off of that. K was at 4, 1, so that moves to 1, 4. Okay, it's always nice to make sure that your point moves to the other side of the line, right? We don't want to not have it move to the other side, right? I'll just write out the other two just so it feels complete. So L is going to go to negative 3, 3, and M is moving to negative 4, 0. So negative 3, whoops. Which is good because L needed to move to the other side, not super far, but decently. And then negative 4, whoops. All right, let's connect them. Let's make sure it's the same shape. And it is, and it looks pretty good. Okay, so we're going to skip the last one, but I did want to show you at the bottom of this is a nice chart that kind of shows you all of them. Doesn't show you when we just have a line like x equals 2 or y equals negative 6 or whatever, but at least for the x-axis, y-axis, and our, whoa. Okay, I don't know what just happened, but we're done. So thank you for watching.